I have a couple of project ideas where I need to either control a bunch of relays or a bunch of solenoids, and PCBWay sponsored this project where I made a 32-channel relay or solenoid driver. It uses the MCP23017 I2C GPIO expander, which I recently used in another design having 8 onboard relays, but this is a more compact board with 2 of these GPIO expanders along with a bunch of ULN2803 drivers, giving me 32 outputs. Each chip can have its I2C address set with jumpers. We would connect up the serial clock and data along with a ground to something else like an Arduino that will control the relays, and the relays have their own power supply right here, separate from the logic supply. So the positive supply for the relays or solenoids will be sent out from this header here, and then when it's time to control the relay or solenoid, the appropriate output will be brought to ground, completing the circuit, turning on that channel. This board has I2C data and clock pull-up resistors, which can be removed from circuit by taking out the jumpers if there's pull-ups already elsewhere in the whole system. I'm going to be using Arduino Uno for an I2C controller, so I'll connect 5 volts from the Uno to the logic supply on this board, which will power the GPIO expanders. The I2C clock and data will come here as well, and the relays and solenoids I'm using are 24 volts right now, so I'm using a bench supply to give 24 and ground on this header. Then 24 volts gets passed on to the output, and that gets used with the driver outputs to turn on the relays. This relay supply voltage is also needed in the driver circuits. Looking at the individual driver schematic, VCC would be the 5 volts from the Arduino, and V+ for the relays or solenoids ends up getting connected to these built-in protection diodes on the ULN2803 to protect the driver from any voltage spikes resulting from inductive load switching. I2C clock and data go to the GPIO expander, and we can choose the address of each of these GPIO expanders with these jumpers here. The MCP23017 has 2 banks of 8 GPIO, so that matches well with the 8 channels on each ULN2803. And when we duplicate this circuit, we end up with a total of 32 outputs we can control just over serial clock data and ground. I explained more about how this GPIO expander works in the other recent video, so just looking through this rather quickly, in this demo I'm using 8 relays and 4 solenoids, so I'm just making note of which GPIO those connect to on each of the 2 GPIO expanders with address 20 hex and 21 hex, based on how I set the address jumpers. So depending which GPIO pin I need to access, within the sketch I have to refer to this library pin number for the GPIO in question, and I have to make sure I'm talking to the correct chip. So I'm calling one of them MCP1 and the other one MCP2, and I initialize each of these with the correct I2C address. And I've given the names relay 1 through 8 and solenoid 1 through 4 to these specific GPIO pin numbers in the sketch. So now if I want to turn relay 1 on or off, I just refer to relay 1 and it automatically goes to pin 11, which is GPIO B3 on the chip at address 20. So after everything is initialized in the setup, all of these are outputs to control, so I set them as outputs, and initially I just make sure they're all turned off, and the loop just goes through every device one by one, turning it on for half a second, and then off for half a second, and moving to the next one, and then it just starts over. So it's just an exercise to make sure everything seems to be working. And if I need even more than 32 channels, I can just chain more of these together on the same bus, set the addresses uniquely, and then I can control even more outputs. Thanks to PCBWay for sponsoring the project, and thanks for watching.